Hello and welcome to CHISEL, short takes, JavaScript inside out. In this episode, we dig deeper into the fundamental but elusive aspects of execution contexts and its phases. What happens during a function invocation, execution stack, implicit variable declaration, and scope chain. Without much ado, let's move on. I've opened up the code editor. I have a couple of files. One, the HTML file, and second, O2 Chisel. It's a JavaScript file, and this JavaScript file is linked to the HTML file. We are line number 7, and let's take a quick look at the code. It is pretty simple, and this block of code is will help us understand the execution context and the phases within the execution context, especially the hoisting and how the function is treated and how the variables are treated during phase one of the execution context. Okay, line number 5 is just a console, and it's a variable grt, short for greeting. So console log greeting, but you could observe that the greeting variable is not defined, right? It's not defined yet. And the second line, you're invoking a function, say hi, which is again not defined before it gets called. But however, you should note that both of them have been, declared, and the variable is declared and initialized later on, and the function definition is also written later in the program. So what essentially happens um, when you run this code, when you invoke this JavaScript file, right? So what would be the output um, from line number 5, console.log of greeting? Will it throw an error, or will it throw a different value, or will it display hello world, right? So let's take a good look at the output. I'm opening up the server, live server. Let's take a look at the output. I'm also opening up the dev tools and navigating specifically into the source file. Okay, and we'll also put a breakpoint on line number 5. That's the entry point, right, of the second phase. The first phase, if I refresh this, you see the first phase is already complete, which is the memory allocation. We discussed that in the previous episode. So the memory allocation for the variables and the methods available as part of, or the functions available as part of the JavaScript file is already done. And we are at the cusp of the second phase, which is the execution phase. It just commenced, but with the help of a breakpoint, we paused the execution. Okay, so now let's observe few things. The first is the call stack. So call stack is a stack memory again, which houses the execution context. And as we know that as and when you start executing the JavaScript code, uh, global execution context, which is the base execution context, is already created, right? So you find the base execution context that we have already seen. Fantastic. And what's the value of the variable greeting, and what happens to say hi, which is a function? So again, I reiterate, function in JavaScript is synonymous to objects, right? So what? So both of these are attached to the global context, and it should be part of your global object, which is window as far as the browser is concerned, right? So let's look at the global, object, and try to spot a couple of things. One is the greeting variable. You could see the greeting variable. It is undefined, right? So why is it? Because during the first phase, I like to reiterate, during the first phase of the execution context, the memory is allocated to variables and functions, right? So And when it allocates that, it puts a placeholder, and that's undefined, which is a special uh, value, you could say. It's treated as a special value, right? So it is set. So the grading variable is set to undefined during the phase one. And what happens to the say hi, the name of the function? Again, this points to the function in its entirety. So let's look at what's the value of say hi. Let's move on. Say hi. Okay, say hi. That's a function, the whole function in its entirety. So this is what it gets pushed into the memory during phase one. We have just completed phase one and about to commence phase two, which is the actual code execution. So what happens when I move on to the next line of code? This is the execution phase, the second phase of the execution context. So I'm just moving on to the second line, which is line number 6. So when you console log, it should print what? It should print undefined, right? So let's look at that. Could see it is printing undefined. Okay, so let's move on. Let's invoke this function. Okay, that's the first thing. And the second one you need to keep a tab on is the call stack. So currently you have the base execution context inserted into the call stack. That's fine. So what happens when you invoke this function? So let's run through the next line of code. You run through this function and you could see the call stack. You have the call stack pertaining to the function created and inserted into the stack memory, the call stack memory, and it is right above the base execution context. So this is a separate independent execution context pertaining to this function, and it is inserted just after or just above your base execution context or your global execution context. Okay, so this also goes through two phases. Okay, the first phase is the memory allocation phase. We don't have any variable to allocate the memory. You don't find anything in its local scope. You could see this local pertains to the variable environment of this function. So the variable environment inside the execution context of this function. So that's the local one. So let's move on. Now what happens is I click on the next line, okay, and the control is in the last line of the function. Let's move on. So clicking, I'm stepping in. You could see the call stack now. So once the function execution is complete, the execution context gets popped out of this call stack, right? And you could also see console log hi already printed. So I finished this program. You could also see the base execution context, the global execution context being popped out of the stack. Let's say that. You could see the call stack is empty now. Okay, this gives you a very basic insight into what's the execution context, the two phases of the execution context. The first phase being the memory allocation, second phase, the actual code execution. And the behavior when you invoke a function. When you invoke a function, a separate execution context is created and pushed inside your call stack. And depending on the lexical positioning of your function, your the position of the execution context of your function inside the call stack differs. Okay, and how this pops out, right? So this is the last in first out mode. That's how the stack works, right? You have seen everything here. Okay, let's move on to the next line of code, the block of code. I will comment this out and start off with the second block, which you know which helps understand the invocation and the execution stack. This is again the function. So we had seen that before, as in when you invoke different functions, the execution context get created. So I will quickly run through this code. Let me uncomment this. Let's run through this code again. Okay, and I shall put an breakpoint. Let me refresh this one more time and look at the code. Okay, so I'll place a breakpoint on line number 23. That's the first line of code when it gets into the execution. Refresh it one more time, and the execution stops here. It's just commencing. Execution is just commencing. So the phase one is already done. So we don't have any variables per se, but you know the function A and function B. So these belong to the global scope. So ideally, you should find the definition for function A and function B inside your global object, which is your window object. You could say that window here. Either ways, right? You can browse through this window object and find A and B. You could see the function A in its entirety, and you could also see function B in its entirety. And even here, you could spot that inside your global object A, function A, and function B. It's identical. And the call stack anonymous, which is the global execution context, is also already inserted into the call stack. So what happens when you execute line number 23, right? So let's step in. A function A is getting invoked. It's already invoked, and you see the execution context of function A being pushed into the stack. Again, I step in. Function B is getting invoked. You could see function B, uh, the execution context created for function B and pushed into the call stack or the execution stack. What happens next? The control moves out of function B. It marks the completion of the execution of function B, so it should get popped out. You could see it gets popped out, and the control is on the last line of function A. One more time, A gets popped out, and the main code finishes execution, and your global execution context is also popped out of the call stack. Cool, let's move on. Let me comment this for now. Let's look at armed with all these basics, right? So let's look at the third one, which essentially gives you an insight into the variables, the variable environment, the local scope, etc. So let's run this code real quick, and let me also place the breakpoint on line number 42. That's the first line of code. Um, when in the when this file gets executed during the second phase of the execution context, I meant. So let me refresh it. Okay, the control stops here, the first line. So the first phase of the execution context is run. The global execution context is run, and you could see the global execution context getting created. And what else we have? We should have a global variable, right? So variable, when I say global variable, it essentially means a variable which is defined inside the variable environment of your global execution context. Pretty simple. The execution context, you visualize it having multiple blocks. One of the blocks is named as variable environment, and inside that variable environment you'll have the variable defined as rank, and it is assigned the value undefined. Okay, it is defined the value undefined. So ideally we should keep it here because this is the first line of code. The breakpoint here, it's the first line of code that gets executed. Okay, I'm invoking this. Okay, so this is fine. So you still have your global execution context created. And what should be the value of the variable rank? Is it 1? Is it undefined? Because remember, the just make sure that be certain that the breakpoint is on line number 40. It means that the line isn't executed yet. Okay, I'm talking about the phase 2. The phase 1 is already complete. So what should be the value of the variable rank? So let's you can add it here, and observe the value. Well, rank is undefined because during the first phase of the creation of the execution context, you have the memory allocation done, and this particular variable is picked up and set a default or a special value called undefined. Okay, so that exactly has happened for the rank, which is part of the global scope. Let's move on to the next line. So you print undefined. Okay, so it's not undefined because here when you moved, the rank got replaced with 1. This is the execution we are talking about, right? So the rank is replaced with 1. In case if you haven't really assigned anything, here for the rank it would still be undefined, but now you have assigned 1, and as you move to the next step, it prints the value 1 here. Now let's see, you are invoking the function a. So what should happen when you invoke function a, right? So you all know that during the function invocation, an independent or an additional execution context pertaining to the specific function gets created. So you find the execution context uh, created and pushed into the call stack named a, and you also can observe that the rank, which is now a local variable inside the variable environment of the execution context of a, and it should be undefined. We are talking about the first run. Okay, so let's check this out. Invoked. Okay, so the execution is in line number 35, which means that this line isn't executed, but however the phase 1 of the execution context of function a is already run. So ideally this rank, which is in the local scope, should have the value undefined now, as of now. Okay, so let's watch this. So we could see the local scope created and the rank is set to undefined. So but what happens when I move the execution to the next line? The rank should get set to value 2. So let's check that out. You could see the local rank is set to 2, while the global one is still 1, right? So the global, you could check the global variable, or you could also say window dot rank, it is still set to 1. Okay, so this is separate. This rank inside the variable environment of execution context a is separate from this rank, which is inside the global execution context. Okay, so don't confuse with these two. So let's move on, and let's get the function b invoked. Okay, function b getting invoked. Okay, you could see this rank, right? So the rank is not assigned, it's not initialized, it is just declared, but it's not initialized, right? So essentially you still have your the value as undefined pushed in, and it just prints undefined here. Okay, and then it's the usual thing, so it gets popped out your call stack. You could see the call stack, b gets popped out, a gets popped out, etc. As we move, you could see, and finally the global execution context gets popped out. Fantastic. Let's move on. Let me comment this code out, and let's move on to the scope chain. Fantastic. So we have 3 different scenarios here, and let's uncomment the first block. Pretty simple, straightforward code. You save this. So you have few functions. Function a, which is with the variable rank, and function b, it's not defined. So here no definition of rank, I just referenced rank here, and at the global level you find rank is initialized to 1, printing the value here and invoking function a. Okay, so let's run through this. I'll set the breakpoint. Let me do this. Okay, not here. This is the entry point. Okay, refresh. Okay, so let's check this. The control is the so second phase execution. The control is in line number 59, where rank is set to 1. Pretty simple. And all other things that we discussed, the function A, function B belongs to the global scope. You find them inside the window object. Okay, so let me also show you this. Rank is currently undefined because you haven't really run the second phase yet. Okay, we are in the cusp of running it. So first line of code where we put the breakpoint does not run yet. Second, let's say the A, that's the function. B, that's again a function. Okay, so A is defined in its entirety, pushed into the memory. B is defined in its entirety and pushed into the memory. So these two are already available in memory, and rank is also available in memory, but not with the value 1, but with the special value undefined. So we are we're just revisiting it. And what happens next? It gets set to rank gets set to 1. Okay, you could see this rank gets set to 1, and it prints 1 here after this. Okay, rank is 1. Now we are invoking function A. Okay, the function A is invoked, and what's the value of the rank here? So let's move on. It's going to be 2. We are setting it to 2, and now we are invoking function B. This is going to be interesting, right? So we have just invoked function B. So let's look at the local scope here. The scope, let's say the local scope, this contains only the this reference to this, this variable. This is pointing to the window. That's fine. But what happened to rank? Rank is not defined inside function B. So you don't find the variable rank inside the variable environment of B's execution context. Okay. And what does it print? Okay. What does it print? It prints 1. Why it prints 1? Because when you are referencing something and which is defined elsewhere, right, probably the outer scope, it picks its value. Okay, so that's the reason. So it picks up the value from its outer scope. So the JavaScript engine doesn't find rank or the variable rank defined within the variable environment, which is again inside the B's execution context. It did not spot it there. So it essentially moved up the scope chain, and it was able to find the variable being declared at the global level. So it picks up the value and prints it. So you find the value printed as 1. So if I'm running this, move on to the next line, you see the value printed as 1. Okay. Again, we revisit this. We have a couple of other scenarios reiterating the same concept, which helps us to solidify the aspects around the scope chain. Let's move on. Okay, not this, right? Comment this out and move to the next scenario. Next scenario is implicit variable declaration. Pretty interesting one. Pretty interesting. Okay. So what have we done here? So we have very simple code. The first line here, the executable line at the global level is you are making a call to the function A, and inside that there is a variable my name. It's a local variable to function, and it's set to Kali, and you're invoking function B. Here it is not actually declared. It's just you define my name to be Shibu, and you're trying to display it. You're trying to access the value of my name variable. It is recall that this my name is not declared within function B, but you're trying to reference my name. Okay. So what typically happens? Will it throw an error, or will it print Shibu, or what else? So what happens under the hood. That's what we are going to experiment. Okay, so saved. Let me refresh this, set a breakpoint somewhere. Mm, I'll set a breakpoint here. So first line, refresh one more time. Okay, so this first execution, the first phase of the execution context is already run, and we are uh, at the cusp of the second phase, which is a code execution phase. And we have the breakpoint right when it entered that phase, right when it entered that phase. Okay, so um, what should be the value now? Let's say the value of okay, the value of A, which is pointing to function A, value of B, which is pointing to function B. That's it, right? So what would be the value of my name? What's the value of my name? Any idea? Or is it available? Is memory being allocated to my name? There is absolutely no declaration at the global level. You could see it, right? So this B is at the global scope, and A is also at the global scope. So A and B memory is allocated. You could find that here, or you can, yeah, so you could see that A and B, the memory is allocated. You could also spot it here at the global level, A and B. Memory is being allocated. But can you spot the variable? Can you spot the variable my name? Okay, my name isn't declared. So you don't find my name anywhere, probably. You could see this, my name. We don't find my name declared anywhere. My name. Okay, so it's not allocated a memory yet. It's not allocated a memory yet. Cool. So let's proceed with the execution. So I'll move on to the next line, which is just to print console log. It's not that console log, sorry. So 78, it invokes the function A, right? It invokes the function A. So let's do that. It invokes the function A, and it's in line number 73. I will add within the local scope. You could see within the local scope, my name is undefined, because as you invoke this function, a new execution context is created. And the first phase of the execution context, a memory allocation. That's the first phase. The first phase is already complete, and we are in that second phase of the execution, right? So in the first phase, the my name is allocated a memory, and it is and undefined is pushed into it. So you find within the local scope my name and undefined. I execute this undefined gets replaced with Kali. You could see that undefined gets replaced with Kali, and we are now invoking function B. So you see the global execution context and inside the call stack, and the execution context for A being created and pushed inside the call stack, just on top of the global execution context. Now see the similar things happening to B. Okay, similar things happening to B. You have the execution context created and pushed into the call stack right over A, and my name here. You could see the local scope, my name. There's nothing, uh, no memory allocated for the execution context of B, because my name is not declared, right? You just have my name and set the value Shibu there, but it is not declared. So what would typically happen here, right? So what the JavaScript engine first looks for the the variable environment inside the execution context of B. So let's assume this is the variable environment for the execution context of B. It doesn't really spot anything named as my name. Okay, so what it does is the JavaScript engine looks outside of B. Okay, it moves to the outer environment. Okay, it moves to the outer environment. Which is the outer environment? It happens to be the global environment. So this is the global environment. Okay, and do we have any declaration? Do we have the my name declared outside of B and inside the global environment? We don't have my name declared. So what the JavaScript engine does in case if this is not running under the strict mode. So strict mode, I've commented it out. If it is not being run in the strict mode, it implicitly creates a variable called as my name. Okay. So currently the global scope, you could see the global scope doesn't have anything as my name. Okay. I can do it here, window dot my name. Okay. It's nothing, right? We don't have anything called as my name here. Uh, let's say, okay. And now when I move on to the next thing, right? When I move on to the next level, let's say at the global context, okay, at the global context, you should have something created, right? So you have this memory allocated, you have this memory allocated, right? You have the memory allocated and it is set to Shibu. Okay, now you move on to the next line, you see the value printed and all other, all other steps, B getting popped out, A getting popped out, and finally the global execution context getting popped out. That's what happens. Okay, let's say this scope. B is popped out, next A would pop out, and finally the global execution context gets popped out of the call stack. Cool. Let's move on and let me comment out this piece of code. Cool. And uncomment traversing the scope chain. Pretty interesting one. So what we have in store here. So we have a variable. It's a global scope. Global scope has a variable called my name here, and two functions, a function A and a nested function. Okay, so the global scope has just the variable name and a function A. Okay, that's what the global scope comprises of. And inside function A, you have function B defined, and inside function A, you have another variable, my name declared and initialized to Kali, and you also invoke function B right inside function A. Okay, so this is the construct. So let's run this code, and as before, we place the breakpoint right on the first line of execution, and I refresh this one more time. Okay, control reaches here. So the global scope should contain two things now. One is my name, which is defined to be undefined, which is set to undefined, and second is the function A, which points to the function in its entirety. Okay, these two. So let's say the B is not available, right? So because B is inside function A. When function A constructs its execution context when invoked, that's when you find the function B being created within function A's local scope. Okay, I delete this off. And you also have this variable created, the my name created. This is at the top level, and it is set to undefined during the phase run, the phase one run. Okay, now I move on, and it gets set to Shibu, and now we are invoking function A. Okay, the function A is getting invoked, and you watch out for the call stack, which inserts the execution context pertaining to A. Okay, click on next. Okay, function A is invoked. You could see the call stack being the execution context for A being pushed into the call stack, and the local variable, right? So was the local variable the scope, the local scope, the function B. Okay, the function B is local to A. It gets created, and the variable my name, which is local to again function A. Now it gets set to Kali. You could see this. It gets set to Kali, and you are invoking function B What would happen when you invoke function B, right? So you have one more execution context pertaining to the function gets created. Okay, now the interesting part, right? So the interesting part would be the my name variable, right? So let's check that out. Okay, the function B gets invoked. You rightly have the call stack populated with the execution context of B. Okay, so what's interesting here is my name, right? So my name, it looks for my name, and within the local scope, we don't find my name. See, only this is available, but my name isn't available. So what would happen? It moves outside of the current execution context. When when the JS engine tries to search for my name variable outside of this context, it goes to the outer context. So outer context is A, not the global context, right? So outer context is function A. And does function A have my name defined, declared, and defined? Yes, it spots my name here. So what it does is it uses the value, it plucks the value and pushes that in place of my name, and it displays Kali, not Shibu. Okay, it's very important. It it displays Kali and not Shibu. So let's check this out. um, so you have the console. You could watch out for the console window here. It prints Kali and not Shibu. Okay, and everything else is same. And one question for you. um, if right, so if this line is not available, right, if line 90 is commented out, what happens to the console.log? Check it out and explain why is why you observe that sort of output. Okay, and let me check the code if there is anything else. So that's it for now. And um, okay, practice this, and especially the question, and I will catch you up with another episode next week. Thank you.